so there's two parts to today's notes, all right? And the first part is the most important part, the part that you're really going to have to know for the test, is how to tell what kind of conic section it is based on looking at the equation. So far, the ones that we've dealt with haven't had an xy term, right? When there's no xy term, when there's no b value, that's going to be the really nice ones that we've been graphing that are centered along the x to the y axis, right? That have a vertical or horizontal axis of symmetry. When there's an xy value, that means that we can have an axis of symmetry that's tilted, which means we can have an ellipse that's off-center, we can have hyperbolas that are like off-center, we can have lots of crazy stuff happening, parabolas that look a lot different, which is where the graphing calculators are going to come into play today. But you can kind of set up this whole discriminant idea. Remember the discriminant from the quadratic formula, b squared minus 4ac? You can do that using this b, this a, and this c. So the numbers in front of the x squared, the xy term, and the y squared to figure out if your conic section is going to be an ellipse or circle, a parabola, or a hyperbola. And so you need to know this, all right? When we have a test, you got to know these rules. If you do this and you get a negative number, if you take b squared minus 4ac and you get a negative number, then your conic section is going to be an ellipse or a circle. A circle is just a special kind of ellipse, right, where the major and the minor axis are the same, so that's why we can kind of group those together. If you do this and you get exactly 0, you're going to have a parabola. And if you do this and you get a positive number, you're going to have a hyperbola. So you can definitely bet on your test. I'm going to give you some questions without a graphing calculator and ask you to tell me what kind of conic section it is. And you can't just complete the square to solve it, because if there's a b term, then you can't separate that, right? You can't complete the square if there's an x and a y there with it. And so that's why you have to know these rules. There are also rules to know what the conic section is if there's not a b term, but I don't want to confuse you, but you might remember that somewhat vaguely from Algebra 2. But we're just going to focus on this, figure out what it is, and I'm also going to show you how we can use the graphing calculators today to graph these and kind of use a form of the quadratic formula. It gets a little messy because you have to solve these for y, but you know, we like messy, right? We're in pre-cal. We're like in May of pre-cal. Like, we can do really hard things now. So. Okay, so we're going to have to solve for y, because on the graphing calculator, if you go to the graph button and you're in function mode, it's y equals. And so we have to get y by itself. So generically speaking, if I was going to do the quadratic formula and I had something in front of the y squared term, a y term, and a constant, remember that the quadratic formula, hopefully you remember the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. I won't torture you with the song. But looking at that last equation and looking at this, it's not that simple, right? It's going to be a little bit uglier when we do this. The same idea is going to come into play here. So let's look at one. Let's talk about the discriminant, and then let's solve it, and I'll give you graphic calculators. All right, so this is kind of the idea, but then look at this. It says classify by using the discriminant. That means based on the discriminant, you should be able to tell me what kind of conic section it is. And then we're going to use some graphing calculators to graph these. And we might not have enough time to do that today, which means tomorrow, I'm giving the ECA tomorrow, and so I'm not going to be back in here till like between 9:30 and 9:40. So it'll work out really well that if we don't get to the graphing calculator part of your homework today, that when you come in tomorrow, whoever's in here, I don't know if it's going to be a sub or just another teacher, but my direction will be to finish the graphing calculator part from your homework using your notes from today. And so when I come back from giving the test, hopefully you'll be ready to go here. So step 1, if we look back at the very first page, it was ax squared plus bxy plus cy squared plus dyx, I don't even know. It just keeps going, right? I guess ey plus f. It doesn't really matter what all these other ones are. It just matters that you know what a, b, and c are. discriminant is b squared minus 4ac. So if I ask you to tell me what type of conic section is it going to be, I expect that you know the b squared minus 4ac, where b is the number in front of the xy term, a is the number in front of x squared, and c is the number in front of y squared. And so if I take that, b is going to be negative 3, a is going to be 2, and c is going to also be 2. I can figure out what kind of conic section it's supposed to be. So then when I graph it on the calculator, if it doesn't look like that, I know something's gone wrong. So that would just be 9 minus 4 times 2 times 2. 9 minus 16. Right? And I don't really care what the value is, but 9 minus 16 is definitely less than 0. Yes? So if the discriminant is less than 0, we would say this is an ellipse or circle, right? Isn't that what the first page says? Ellipse. And we really could just say ellipse. Circle is just a special ellipse, but I'll say it like that. You definitely are going to have to know that for your test. I haven't decided yet if there's going to be a graphing calculator portion of the test. If there's not, then I'm not going to make you graph this on a graphing calculator, obviously. So we'll see what happens. I'm guessing not. We're kind of out of time, but we'll see. But here's what I want to show you how to do this. If we want to get this in the form of quadratic formula, like ay squared plus by plus c equals 0, notice I changed the lowercase letters. The y squared term is obviously going to just be the y squared, which would be 2y squared. And in this case, we only have one thing with the y in it. Do you agree with that? So the middle term would just be minus 3xy. C is everything without a y. Do we have more than one thing that doesn't have a y in it up here? So the c term is really going to be like plus 2x squared minus 2x. So I'm going to kind of show you this. Like I'm going to call this my A. This is my B, right? Everything in front of y. And all of this is my C. So the different part about doing this quadratic formula is you're not going to get a number answer. You're going to get an equation that has x in it so you can type it in your calculator. Right? Because we're trying to get to a point that we can type it in our calculator. Can't type this in my calculator because my calculator will say error because I have to have y by itself. Okay? So here we go. So y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's up to you on how much you simplify this. If you're really good at typing parentheses in, you don't have to simplify a whole lot. If you mess up parentheses a lot, you might want to simplify a little bit more so that you don't have so much to type in your calculator. But we're really just going to plug this in. So negative b, is that just going to become positive 3x? Not that calculator. We need a graphing calculator. Just hold tight. Plus or minus the square root of b squared. You could say parenthesis negative 3x squared, but I'm just going to say 9x squared. Are you okay with that? Minus 4 times a, which is 2, times c, which is 2x squared minus 2x. 4ac. All over 2 times a. Do you see where I'm getting those numbers from? This is where graphing calculators, some people think we should get to use graphing calculators all the time in here. It's a pain to use a graphing calculator sometimes because you have to get it to the form that you can type it in. So if you wanted to, you could just type this in directly, but I'm going to clean it up just a little, not much. I'm going to say Okay, 9x squared. We could just say 8 times all this, or I'm going to go ahead and distribute. 8 times 2 would be minus 16x squared. You agree with that? And negative 8 times negative 2 would be plus 16x. I like that because it saves a whole bunch of parentheses. You could even put that together, right? Those are like terms, but it doesn't matter. All divided by 4. Notice there's a plus or a minus, which means you actually have to enter 2 of these in your calculator. You have to do the positive half and the negative half, because this is not going to be a function. Think about hyperbolas and ellipses and circles. They're never going to pass the vertical line test, so you're always going to have the plus or minus when you do this. You want to learn how to enter stuff in your calculator. When you type a square root in your calculator, it's going to automatically put a parenthesis. So when you're done typing in that square root, you're going to want to close that parenthesis. If you typed in up here, you got to make sure everywhere that you open a parenthesis that you close it. If you don't do it right, your calculator will tell you there's a problem. Or if you just leave unclosed ones at the end, it's not going to graph the right thing. And so that's where you have to get better at using graphing calculators. Something else that you have to know how to do is if you're typing a fraction in, your calculator is going to do order of operations. So if you want all of this to be on the top, you have to put it all in parentheses. All right, so if you don't do that, then your calculator is just going to take the square root and divide it by 4 and not take all of this and divide it by 4. So let's all get a graphing calculator and let's type it in, and then we can try that answer. Step 1 is we were graphing in polar mode and everything the other day. So step 1 is you're going to want to go to mode, and you're going to make sure that you're in function mode. You'll know if you go to your y equals and it's not y equals.
Is there a plus or minus button?
There's not. You have to type it in twice.
All right.
Go to mode and go to function. Like it's like the 4th or 5th one down. This is something if you are taking calculus next year, we will use graphing calculators a lot more. You actually get to take the calculator home with you every day. And so it's something that will practice more, but you want to be comfortable being able to type something there. See, I'm in R mode too. So go to mode, and mine has a lot more options than you do, but function is what we want. And you'll know you're in function mode if you go and it says Y1. And I'm going to type the whole thing in parentheses because that whole numerator needs to be in parentheses. So I have 3x, and remember that your variable is always right here next to alpha, no matter what mode you're in. If you're in function mode, it should show an x, and you're going to have to do this twice. You have to do the positive and the negative root. So I'm going to do plus, and mine's a little fancier than yours, so when I do a square root, it automatically puts it under a square root bar. Yours has a parenthesis, so you have to it starts a parenthesis for you and you have to close it, right? Mine doesn't, but I can put a parenthesis there just so you can have the same thing that I have. 9x squared minus 16x squared, and I could have added that together, but I didn't, plus 16x. And then when you're done under the radical, you have to close the parenthesis. But you also have to close the numerator to say, hey, this is everything that's in the top, so you got to close another parenthesis. I always check how many parentheses did I open, and I got to close the same amount, and you got to close them in the right spot. And then I'm going to divide by 4. If you were dividing by addition and subtraction as well, you would need to put the bottom in parentheses because your calculator does order of operations, and it will multiply and divide before it adds and subtracts. And unfortunately, there's not like a copy and paste button here, so you just have to do it again, except for change that to a minus sign. So the nice thing is you can always check that they look the same, except for the minus sign. So minus square root 9x squared minus 16x squared plus 6x seem to fit on the page still. That doesn't seem like it fit on a page. Did yours fit way better than mine? I'm just gonna zoom 0. It's supposed to fit it to the screen so that the whole picture would be on there. And mine's kind of cool because it's different colors, so you can see the positive and the negative side of it. But yours should graph in those two sections, so you can see the positive side and the negative side together make that ellipse. If you did not get an ellipse that kind of looks like that, then that means you typed something in wrong. On your homework, when it says to sketch it using a graphing calculator, what I want you to do is roughly sketch that, not a lot of points, but like if I was going to graph this on my paper, I would just say, well, it kind of starts here, and it kind of goes out, and it looks sort of like this, right? Like, that's a good enough sketch of your graph to just show me that you graphed it, right? What? I don't know, because it's just weird. It should close all the way. If we zoomed in, what is that? If we could figure out what that point is, I promise that it actually is connected there. It's just not closing, right? Like, it should close. It's because it's negative, like you have the same as phone. You know what I'm saying? Like it was the same thing as this negative. So all of the ones we have graphed, the major and minor axis have been horizontal and vertical. And so when there's that xy value, when there's that b term, it's going to make the axis of symmetry not vertical and horizontal. So you can see here that the major axis and the minor axis would kind of fit like that. Okay? That's kind of cool, right? I'm thinking there should be a graphic calculator portion of our test. I like this stuff. All right. Let's do another. Maybe. Ooh, how about this one? Yeah. Let's do our b squared minus 4ac first. If you do the b squared minus 4ac, it lets you know what type of conic section it's going to be. So then when you graph it, if it doesn't look like that, then something has gone wrong. And again, it's usually written in the right order, ABC. So this would be 36, because negative 6 squared, minus 4 times 1 times 9.
It's not the same point.
There's an extra term in there, but A, B, and C are in the right order.
There's no way.
I got that this equals 0, so this is what you really have to make sure that you know. You need to know which one is which. If it equals 0, it's a parabola. Which is kind of tricky because there's both an x squared and a y squared, but that b term, that xy term is going to make that parabola not just open up, down, left, or right. It's going to be kind of like to the side, and so that's why there are both squared terms in there. I wanted to do this one because I wanted to show you that there are 2 y terms in here, right? So last time C had 2 terms, B can also have 2 terms. So I always group them together. It's up to you if you want to rewrite it, but I always write it as y squared, y, and then the constant. So again, I'm going to start with my 9y squared, but notice that both of these have a y in front of them. So if I factored the y out of that, I would be left with like, I don't know how we want to write that, negative 6x minus 2, plus sign there, y. You see what I'm doing there? Like I took the y out of both of those. Just like on the last one, there were 2 c terms. So if these both have a y, that means so this is my a, all of this is my b. So I took care of this, I took care of this. Anything without a y or a y squared is my constant. So then I'm going to have plus x squared plus 1. That expression is my C term. That's exciting, right? So maybe we can practice typing a ton of parentheses on our calculator. So, quadratic formula. Y equals negative b. It's up to you on how you want to do this. But if I take the opposite of this, since these are both negative, is it okay if I just say that my b term is 6x plus 2? Or if you really wanted, you could say negative parenthesis negative 6x minus 2, but I'm just going to say 6x plus 2 plus or minus the square root of b squared. Now you could FOIL it out. I'm going to just say negative 6x minus 2 squared minus 4 times a, which is 9, times c, which is x squared plus 1, all over 2 times a. Is it okay if I just write 18 down here? Again, it's up to you on how much parentheses you want to use. I probably would go ahead and say this is 36 here. You could even distribute if you want. But I'm not going to FOIL this out. To me, the more computing I do, the more chance I have of making a silly arithmetic error. So I'm just going to type it in with a bunch of parentheses. Remember that you have to put parentheses around the whole thing when you type it in your calculator. And that your calculator is going to automatically open a parenthesis under your radical. So no matter how many parentheses you use in there, you have to close that under your radical as well. And so if you feel like you want to multiply that out more, you can. I'm going to change that to 36 when I type it in. But other than that, I'm going to leave it. Because all you're trying to do is get y by itself. And as long as you type it in correctly, we should get the right thing. So let's go back to my lovely calculator here. So parentheses 6x plus 2 plus the square root of, and I'm going to parentheses like you do, and then I have to put that next one in another set of parentheses, so negative 6x minus 2 parentheses squared, right? And then I'm going to say minus 36 times parentheses x squared plus 1 parentheses, and then I'm going to close the parentheses under the radical, and then I'm going to close the parentheses on the top, and then I'm going to divide by 18. Mine just keeps going. Does yours go down underneath as the second row? I like that better because you can see it all. I can't see all mine. Let me go back up here so you can see this. I always like to check when I type the bottom one in that they're like the same length, because that means I use the same number of parentheses. All I'm going to do is change this plus to a minus. Let me go back to the end here if you need to see this. If you typed it exactly like I did, you should have 3 parentheses in a row, because you should close the x squared plus 1, you should close the radical parenthesis, and then you close the top of the fraction parenthesis. If you multiply stuff out, then yours might look different than mine. So then I'm going to do the same thing. 6x plus 2 minus the square root parentheses negative 6x minus 2 parentheses squared minus 36 parentheses x squared plus 1 parentheses divided by 8. Perfect. Oh no, mine says error. Did yours work? Go to. Oh, look what I did. I typed a minus instead of a negative. If it ever says error and you hit go to, it'll take you to what the problem is. And so look, I typed a minus instead of a negative.
Where does it say go to?
Under, like when it says error, it should say quit or go to.
I just need batteries.
It's dead. Oh, it's still working right now.
No, it's not.
It is.
I think past. Didn't say batteries.
Yes? It's a lot of work to do. But, it's kind of cool to see the axis symmetry going in slanted. It's alright. It's alright. Just look at it. Yeah, I think it just looks different, standard because it's just from the window, but I think that's right. That's what I'm doing. That's fine. Yes. Okay, let's look at one more. I think this is like as bad as it gets when there's a y term that has a sum or difference, and when the c term has a sum or difference. Like it looks kind of ugly, but once you get the process down, it's just getting y, plugged in the quadratic formula, and then typing in your calculator. And then sometimes it's not that bad at all, like the next one. Again, I'm going to start with my discriminant, which is b squared minus 4ac. Be really careful on this one, though, because I think the c term is 0, right? Because the c term is the y squared term. So you just got to be really careful on what's missing from there. So on this one, if we plugged in 5 squared, negative 5 squared, we get 25 minus 4 times the a term is 2, but the c term is the y squared term, and there isn't one, which means that that's just going to be 25, and it's the only one we haven't done, which is a hyperbola. So we could do the quadratic formula again on this, but there is no squared term, right? So I just want to remind you, if there's not a squared term, this isn't really a quadratic equation anymore in terms of y, because there's not a squared term. That we can really just solve for y here. A little tricky, but could I just subtract 2x squared to the other side? Move that over. And if I wanted to get y by itself, could I factor the y out of both of those and change that to negative 5x plus 1? And if I wanted to solve this for y, I think it would look something like that. Trying to get so I can type in the calculator, right? Trying to solve for y, you can do the quadratic formula just like we did, except for a is 0. So if you want to do the quadratic formula where a is 0, I promise you're going to get the same thing. That's quadratic, yes, yes. Why am I not doing that here? Because there's no y squared. You see what I'm saying? So I'm just trying to show you that I think it's easier than doing the quadratic formula, is just get the y's together, factor the y out, and you can solve for y. Does this look like something that we have done in the past? This is just a rational function. Do you remember when we graphed rational functions and they had asymptotes? And they kind of looked like this, like sometimes they look like this. Does that kind of look like a hyperbola? The 2 branches? Yeah. So a rational function kind of could be thought of as a hyperbola, depending on what it looks like here. But when you type this in your calculator, you are going to see the 2 branches, and they're just slanted instead of going up and down and left to right. So like the axis of symmetry, or the whatever you want to call it, transverse axis, converse axis would be going through something like that. So there's like a horizontal asymptote and a vertical asymptote. I like that one. Some people might not like it because it's different, but to me it's way less work than the other one. So that one's much easier to type in also, but remember to put this in parentheses when you type it in your calculator. Let's go stress about time. We'll be around 3 minutes. All the time in the world. There's no bells, so I can just keep it forever, right? Negative 2x squared divided by, what was the bottom? 3x, 5x? Hold on.
so unprepared.
4, 6, 11, and 12, you have to graph. My suggestion to you tonight is do the b squared minus 4ac so you know what to expect. And when you come in tomorrow, you are going to have to get a graphing calculator and graph and sketch those on your paper. 43 through 48, I believe, are just saying what type is it. Like, you don't have to graph it. But these 4 tomorrow morning, that's what you're going to do before I get back in here from the test. Okay?
Okay.
Okay. Goodbye.